from now, we start talking in English with Behuz. Behuz is a dear friend. We know each other since 2012, 10 years since we met each other in France, in Grenoble. So Behuz is a research scientist in Amazon with focus on interactive data system. He has held position in Naver Labs, Europe, the Grenoble Alpes University, and also the Ohio State University. His research interest is in the area of data management at the crossroad of machine learning and database. He has published more than 40 papers in top ranked international conference and journal in data management area. So it's a researcher in database domain. So he has visited us in 2017, and we had the opportunity to to have a lecture in IFRN. So thank you very much, Behus. I know that you are busy and you have a lot of things to do in your daily life. So thank you very much for accepting our invitation. So it's with you from now. Thank you very much.
Sure. Thank you very much for the introduction. I hope you hear me well. I think it's good. Yes, let me bring my slides. So so with this introduction, let's delve into the talk. So it's about automating interactions. I'll elaborate more on the topic later. Let's also add to what Placido mentioned. Yes, in 2021, I was in France. I held positions there in Naver Labs Europe, which was a Korean tech company, and also, I held positions in academia and the University of Grenoble Alpes. And then it's been a few months that I moved to the US and I joined Amazon. Now I was also in Natal like 5 years ago in person. I had this opportunity thanks to Placido, and we had great time there. Hope I can visit soon again. Great. So let's delve into the topic. And I know the discussion today is about the pandemic and its relation with what we do as computer scientists. So I was thinking about the relation of the pandemic, or the impact of the pandemic on the way that we work, and it's specifically us computer scientists, computer engineers. And it's very straightforward that this pandemic has revolutionized the way that we worked before. So most of us work from home. Most recently, things have started to be hybrid, but still this culture of working from home is something that is there and is with us in all companies, in universities, in academia, in everywhere, right? So it's very evident that pandemic has changed the way that we work. And it simply means that we are doing the same work that we were doing before, but now with new ways of interaction. We have new structures basically for interacting with each other to perform a task. Of course, we have all these communication apps, from Zoom to Skype to different apps, but we also utilize different online services that we were using before, but now we use it even more heavily, like cloud services like Google Cloud or AWS, Overlay for writing papers, Jupyter Notebook for easily sharing our codes, and many different online tools. So the conclusion here is that it seems that the style of work that we had before, that we were going to offices and we were doing things, have um, become more structured and have found like a similar structure in most of different things that we do here. Um, so with these, a question that I'm personally interested in, and I want to share this curiosity with you, is that um, can these interactions, which are now structured, be automated? So, in other words, now that the pandemic has proved to us that we don't need to be there at work in person, we don't need to have some sort of customized interactions in meetings, in classrooms, and whatever, but these tools can already help us to form our interactions around. Can we go one step further and get help from algorithms to make these interactions automated? To mention this question a bit more technically, it simply means that given this kind of interactive nature of information seeking tasks that we humans do every day to perform our tasks, whatever it is, as a data scientist, as a research scientist, as a professor, as a student, how is it possible to represent and learn this user behavior so that we can guide humans in interactive recommendation settings? I elaborate more on this later. But this is the question that I want to focus on today. And does it mean that we want to just hand off all the tasks to robots and do nothing? No, I'm not advocating that. And this is not really the topic of today's discussion. I'm more talking about, the term mixed initiative systems, where we automate interactions that humans do so that machines and humans can work hand in hand. We know that there are places that humans are better than machines, and there are also other places that machines are better than humans. So there could be this kind of symbiotic autonomy or collaboration between machines and humans, so that humans can perform better, right? And this is what we're going to talk about today. So in the rest of the talk, maybe in the next 15 minutes or so that we have for this talk, I try to cover this outline. So first, I introduce briefly what I mean by information seeking, what I mean by interactivity, how can they represent interactivity, and finally the main question, the $1 million question: how can we learn interactions so that we can guide humans with these algorithms? And then I conclude. Okay, so let's start with the introduction. So what we mean by information seeking, it's a typical topic. We know that before. So we have typical paradigms of information seeking in the state of the art. We search things like in Google or whatever other search mechanism, or we consume recommendations in Netflix for picking a movie, or in any other apps around us. So usually search and recommendation are typical forms of information seeking for us. And in terms of work, for example, we also do the same thing, right? So if we are coding something, we go to Stack Overflow, we search for a problem that we have. What is this way of merging two data frames in Python, for example, and we find the result, right? Or maybe there are these autocomplete services in most editors when we are writing code in Python, Java, or whatever. This is like in the notion of recommendation. So this notion of information seeking is something that we always have. And in every information seeking algorithm, the input is some prior knowledge. Either is a query or question, basically, or a history of what we like. So based on this history, recommendation systems, for example, can work. So this is the status quo. We know what is information seeking. The problem with information seeking is that usually machines have a very low understanding of what we are looking for. So For example, again, the question that the scenario that I mentioned earlier. So in Stack Overflow, you go and ask a question about one of the issues that you have in coding. But it's not the final objective. It's just one part of your problem. Then your objective is going and developing, a code for another objective that you have, for a bigger objective, let's say. But machines are agnostic about this objective, and this is basically the problem, that there is not, a full connection between our objectives and machines. And this is in the nature of information seeking tasks, because in nature there are one-shot systems. You go there, you ask a question, you get an answer, and that's it. You're done. Then you can ask another question, which is totally independent from the previous question. So we have this notion. So I won't enter into too much details about that, but the whole notion is that there is subjectivity in information seeking, in the sense that machines cannot totally understand what we mean when we ask something or when we ask for recommendations. And this is, the whole process of, single shot architecture and multi-shot architecture when we seek information, as I mentioned before. So typically we have, the figure on the left, where, you as the user come with some prior information. The engine, be it Google or whatever, make some calculations, and it gives you the results, and it imagines that you are good, you leave, and then you can come back later with an independent request, another independent request. What we want to advocate today is that there is this notion of multi-shot, or let's say interactive architecture, where the system still serves you with some information, but then you provide feedback to the system. And this feedback will improve the way that the system will provide information, better information in the next iteration. And this kind of feedback guide loops go on until you're satisfied with your system. So with this kind of interactive information seeking paradigm, what happens is that both the user and the information seeking system will improve through this conversation that they have together. So through iterations, through interactions, the user will clarify the subjective task that she has in her mind, and also the information seeking system will comprehend better the needs of the user that it has to satisfy, right? So it's a win-win situation for both. And this is where I say that this is a mixed initiative systems, right? So they both work together to achieve a task, right? Let's see a more clear example. I won't delve into the details of this example, but just to better understand what we mean by this kind of mixed initiative systems, providing feedback, getting guidance. What do we mean by all this? So imagine we have this user, Luna. She wants to buy a camera, for example, in Amazon website, and then but she doesn't know which camera is good, and she doesn't even know what attributes she should focus on to get a good camera, right? She has no idea. She just has this fancy of buying a camera. So what should she do? So what happens, for example, in an interactive paradigm is that she starts looking for some general idea. Hey, I'm looking for some full HD cameras because I know that video quality is important for me. Then the system would provide some options that things best capture the request of Luna. Then the user will provide some feedback that, well, in these options, some of them are good, some of them are not really interesting. Based on this feedback, again, the system will provide yet another set of options. And this loop continues on and on until the time that the system and the user land on a decision to purchase, for example, this Canon PowerShot camera. Okay, so this is how this kind of interactivity between users and systems work, right? So now that this notion of interactivity exists and we can capture that, and I hope that we're convinced that this can help serve a better information seeking. Now the next question is that how can we represent this interactivity? We need this interactivity to be represented so that algorithms can, mimic the way that we represent interactions as humans. So how interactions can be represented? The framework is very simple. And again, I don't want to enter into the details. I just present the highlight level, but it's very simple. So basically, each interaction happens between two iterations, iteration t and the next iteration, iteration t plus one. In the first iteration, there is always a set of options provided by the system, and there is a feedback which we call small d, provided by the user, which shows, for example, this is the one that I liked among all the choices that the system provided. Then in the next iteration, there is a set of guidance, which means the list of options that the system provided based on the feedback small d, and this guidance we call it big D. And we define a function which is called explore, which makes this transition between iteration t and iteration t plus one. So this function admits as input the feedback and a semantic of how to move from this iteration to the next iteration, which is domain dependent, and also a parameter k to say that how many options should I provide. K could be equal to 3, for example, in this case, where the system will provide 3 different options. So with this simple function, we can basically capture most interactions happen in the state of the art and in different applications. And then this semantic of exploration can be different with different interestingness functions, for example, which are defined in the literature. For example, I can say that I want to move from iteration t to iteration t plus one, and I want to maximize diversity in the options that I see. So now I have a semantic for this transition. Or I can say that I want to move from iteration t to iteration t plus one, and I want to keep a very high relevance on the sentiment, on the textual aspects of the options that I just saw, right? So there are different options that we can play here. I think it is more domain dependent, and it depends if we are designing an interactive system for example, Stack Overflow, or for a data science task, or for buying a camera, for example. Exploration semantics will be different, but the structure will be the same, and we use this explore function to represent them all. Okay, moving forward, I just move directly to some results, some numbers, to see how these interactions work. So basically, this is a result from now I can say from an old paper. It's like 7 years ago, and in this paper we focused on the interactive task of selecting a program committee for a conference, for example, right? So we know that program chairs are responsible for different conferences or workshops to pick a few members from academia or industry, and usually they have some subjective constraints, right? So they say that these members should be diverse in demographics. They should be, maybe the gender should be balanced. Maybe the seniority should be balanced. We should have junior and senior members, and they should be relevant to the conference. We have some vague ideas, right? And now the question is that can we formalize the interactions that a program chair makes with a system to pick these people. And we formalize this system, and we notice that by having semantics of exploration and employing this explore function that we said, we can basically capture the ground truth of program committees in many famous conferences such as SIGMOD or VLDB or SIGChem in less than 20 steps. So users, with a good definition of semantics for explorations, users are able to reach 50% or 80%, like a good part of the ground truth of those PCs in very few number of interactions. So this simply means that this simple form of defining exploration works, and we have a good model of the interactions. This is just to define this. And now I will put more time on this part, and then I conclude with this part. And now that we know interactivity is good for information seeking, and now we have also a very simple but effective model for formalizing interactions. Now here's the million-dollar question: that can we learn these interactions, right? So we know that we are living in an era that we want to have supervised learning methods for everything, right? And we see things everywhere, from self-driving cars to prediction of future prognosis in medical domain and in many other places. But now we are talking about human interactions, and humans are messy creatures. They do things around. They don't really have a structure. And now the question is that, can we learn these interactions? What I want to highlight here in terms of learning interaction is that there is a fundamental difference in this learning problem with other learning problems, like, for example, learning to play chess. And the difference here is, again, the heterogeneity of the behavior of users. This is what makes this problem challenging and at the same time interesting to look at. So it's not yet another learning method, and it seems that we need to have more focus here. Let's pick up our model and see how we can have this model in terms of a learning framework. So we already saw this exploration function, and with this exploration function I can say that I have a series, or I have a sequence of these exploration functions, and they make an interactive session. So the user starts a session. It provides the user will provide a feedback, a guidance will come, another feedback, another guidance, and it goes on and on. And then this makes a session. So we have a notion of a session, and we know that in this session we have states and we have exploration actions. So states are every stable position, right? So for example, when you receive some information, for example, from Google, it's a state. So you land on a state, you observe some data, and then maybe you can provide feedback, then you switch to another state, you transition to another state. And there are also some exploration actions that we defined before, that in each state you pick an exploration action to transition to another state, right? Now what we want is something that we call a policy. And basically by policy I simply mean that I want an optimal mapper between states and actions. So more simply put, I simply want to have a mechanism which can tell me what I should do in each state. As simple as that. And then this is what I want to learn. And then the question is how I can learn that. And basically in this figure below this slide, what I see is that there's a user. She has made some interactions up until now. At some stage, she has no idea what to do next, right? Or maybe she needs help. And if we have a learning mechanism that can help us with this next action recommendation, given the current state, that would be very beneficial. And this is the topic of today. So of course, the whole question boils down to this notion of a policy, and then how can we have a good policy? Again, I'm repeating myself that this is not a typical learning mechanism that we can say that, okay, with higher accuracy or with higher precision of recall, we can say that we have a better learning mechanism. It's all about it's a new mechanism, and then we have to rethink about, revisit the definitions, and we have to rethink how a policy could be good. And basically, the way that we define that is that because it's an interactive process, so in each step, if I have a notion of reward or utility, and if I can increase this utility throughout this interactive process, I can say that this policy is a good policy, right? And how can I define the notion of reward? Basically, it can be as simple as an intersection between the target that I have and the current state that I am, right? If the place that I'm currently in is very close to the ideal target that I should be in, I get a very high reward. But if I'm very far from where I should be, I get no reward, or a very low reward, right? So this is the idea. We have a notion of reward. With this notion of reward, the goal, the optimization goal, becomes maximizing this reward, right? And basically, what I mentioned fits perfectly into the reinforcement learning architecture, right? So people have discussed a lot reinforcement learning in different disciplines. Of course, it's leveraged more for games, and um, you know it's been more successful in games. But here we want to, with all the descriptions that we had before, the sessions and exploration actions and the states, we want to, employ reinforcement learning to learn policies for exploratory behavior, right? And this figure below shows, how we want to do that. So basically, what we are doing here is that we employ an agent in an offline process, which goes and makes some random walks, it makes some random explorations, right? Just explores the environment and gets some feedback, gets some reward. And with this reward, it tries to, maximize this reward. It tries to understand what is the policy that can maximize the reward that it can get. Everything happens offline. So we expect that at the end of this offline process, we have a policy which knows what to do at each state. Now with this, I move to the online phase. Now I have the user provides feedback, and now the system knows what to do with this feedback to go to the next system, to go to the next state, right? So this is the whole aim here, right? And a bit more technicality here. So when you're talking about optimal policy, usually in reinforcement learning, it means optimizing this equation, right? So we have this Q function, which says that what is the value, or what is the cumulative reward at this stage given a state S and an exploration action E. And if we get the max, the value of the action whose value of Q is max, it simply means that we are picking the best action, and we are optimizing the policy towards picking best actions. One of the last things that I want to also mention here, I think I'm out of time. Let's just quickly mention that. We talked about the states, and how a policy can learn what to do in each state, but usually states are very discrete and independent. For a better learning, as we also do in typical learning, we can consider context. We can consider some contextual features which describe the states. So instead of looking at each state and learn a policy to know what to do at this specific state, we learn what to do given a set of contextual features, right? So we generalize the learning in this case. So I can elaborate more in questions about that. With this, we had some experiments. It basically shows that with more simulation sessions that we have, with more interactions, the agent can learn better, and the number of steps that we need to reach target decreases. It simply means that the agent is learning. And there are many different paths to follow after that. So we discussed about single rewards, we can easily consider that we have a system that provides different semantics of rewards, right? And then how should we do that? We can also consider a case that we have multiple tasks. So imagine, in simple case that, imagine we are training, a reinforcement learning algorithm which can play both chess and backgammon, right? It's an absurd example, but in our case, in information seeking, we can also think about, how policies can do two things at the same time, or can learn to do two things at the same time. And there is also the question of domain knowledge. We said that, the offline process is always random and without any prior knowledge, but maybe we can also insert some prior knowledge into that so that policies become wiser in this case. Okay, so that was it. I'll stop here and then we continue with questions. So basically the takeaway here is that I just wanted to say that human in the loop information seeking is a necessity for today's ML applications because we have subjectivity and we want to obviate that. And seems that reinforcement learning is an appropriate model for that. And then we showed that, how things works with reinforcement learning and how we can learn things. So that's it. Yes, I hand it to Placido. Thanks.
Thank you very much, Behus. Thank you for your talk, your lecture. So it's time for questions. So we have some questions here. So the first question is from Esther Vanderlei. Here is the question. Good afternoon. Which are the ethical limits for personal data usage?
That's a very good question. Ethics matter a lot, and my research was highly investigated before on understanding people based on their demographics, based on their professional, all this, and then things have changed in these years. So now the model that I just presented, let's just focus on what I just presented. So we are dealing with interactions, we are dealing with behaviors, right? And so of course things can, some identity can leak here, and of course we have to deal with a layer of privacy on top. But it seems that just looking at the behavior alone and not considering any kind of bias on the gender or any other age or any other demographic attribute can work in this mechanism. The system wants to just understand how people in mass do things in sequence. And this is why that I think we are almost safe in ethical domain here, but I agree that a layer of privacy on the top would help.
Nice. We have another question about ethics, including your experience in Amazon. How does Amazon address the issue of ethics and privacy in data handling?
So Amazon is not an exception. I think the practices here are the same as almost everywhere else. I can just point to two practices. One is that inside Amazon, we as research scientists or data scientists or whoever who play with data, we have no access to identified information. So it's like everywhere. So customers in when you search a query in Google, or you shop something in Amazon, or you do some interactions in Facebook, then inside the company it's a responsibility for the company to just encrypt everything, and so it stays between you and yourself and your friends. And also the second thing is that there is always this right to remove. So now with GDPR in Europe and similar laws in other countries, you're able to ask all the platforms to remove, and they have the responsibility to do so.
Great, it's good to know about that.
Yes.
Yes, for sure. We have another question from Eduardo Vanderlei. Which is the cultural impact in machine learning algorithm? Do you believe that culture impacts a lot in these interactions?
That's a very good question, and it's an open question. So because we didn't have a chance to really look at this dimension, and it needs investigation. Uh, what we investigated was on different expertise levels. For example, that the same system is used by a beginner or an expert, and we see that the same system is leveraged in different ways. Um, and I also imagine that other things can also happen. This is why that I mentioned uh, earlier that I think uh, this semantics of exploration is something very domain dependent, and this domain can also be interpreted to culture, to work dynamics, and many different things. And this is where that I think we have this big framework, but inside this framework, components can be translated and can be adapted to different cultures, domains, expertise, and different aspects of that. That's a very interesting question. Thank you.
Consider this last question. I have one question considering the different ways that human interact with themselves. So human has different ways of interactions. The way I interact with you is different that I interact with another person.
Yes.
Do you believe that in the interaction between human and machine you have different type of machines, right? So maybe machines must have also different ways to interact. Do you believe there is only one way of interaction between human and machines, or do you believe that the models must consider the different ways that human beings interact with each other or machines, and because the result could be different, right?
Yes,
Depending on the
absolutely.
type of machine.
Yeah, absolutely. Yeah. That's also a very interesting question. Absolutely. Yeah, it's so the short answer is that of course it should be different as it is also in human interactions, and also but the thing is that there are, it is twofold. On one side, um, we need this kind of uh, infrastructure where
That's for sure.
we formalize everything, and there is one channel that every interaction goes through, but with different semantics, right? And with this, I didn't show some experiment, but for example, we had experiments where we were training policies on one task, and we were testing it on another similar task, and we were seeing that things are working. It's not that much bad. So it seems that this general framework works, but there's a limit, of course, and there is a place that we need more customization. And now there are all these discussions by uh, giants of reinforcement learning and machine learning about self-learning. So
Okay.
self-learning is now a very nascent domain, that machines learn how different people interact. Machines can learn the definition of interaction, right? This is the
Okay,
next
this
level.
is also
Right,
okay.
right. Yes.
We have
This
two
is the
more
future,
questions.
basically.
Yes, for sure. Esther Aragon say, hi, Behus, congrats for the talk. I think the choosing theme is very interesting. You are a data science, right? Can you talk a little about the work challenge with big data?
Sure, absolutely. There is a nice quote recently that people refer to, and I like it. And people for years, for a decade, talked about big data, and the bigger, the better for deep learning algorithms, for example. And the more data we have, we can do better things. But now people say that don't focus on big data, but focus on good data. And I think it is the biggest challenge as a data scientist, as a research scientist, as someone who works with data. So I think if this is the answer to the question, most of my time uh, in both in academia and now in industry is on making the data ready for whatever I want to do. Then the last part, which is learning, we have tons of different frameworks and methods which are just ready to just plug in the data. But so the challenge for me is first, especially in a company with billions to trillions of data, first is to understand what is this data about, what are the attributes, and then the second challenge is that to get a clean subset that I can work on. These are the two main challenges here.
Right. Because thank you very much for your talk. Thank you
Thank
for
you.
your availability. We have a message from Mariana Macedo. Amazing talk. Congrats,
Thank
Behus,
you.
for speaking in an easy way to understanding. So, my dear friend, thank you. You see each other in other opportunities.
Sure.
So, have a really nice day in United States, California, and also send a hug to Shadi.
Sure. Thank you.
See you.
Thank you, everyone.
Thank you very
Sure.
much.
Thank you. Thanks.